In this video, we're going to solve definite integrals using integration by parts. And so in the previous videos, we solved a bunch of indefinite integrals using integration by parts. And so the process we're going to use here for definite integrals is very similar. At least the skills we're going to need to use are going to be the same. So we're going to identify u and dv and get u du and v and dv. But then when we write out this formula here, we're going to write it this way. So the u times v, we're going to evaluate that from a to b. And then the new integral is just going to be going from a to b. That's it. All right, so cosine is easy to both integrate and differentiate. And we'd rather differentiate x, but it wouldn't be bad to integrate it either. So we'll say u is equal to x. So du is equal to dx. dv is equal to cosine of pi x dx. So v is equal to 1 over pi sine pi x. All right. Therefore, 0 to 1/2 x cosine pi x dx. U times v okay, going from 0 to 1/2, right, all of this, minus the integral from 0 to 1/2 v du. So let's take out the 1 over pi sine pi x dx. Okay, so we've got, at 0, this goes to 0. So we just have minus 1/2 or 1 over pi times 1/2 times sine of pi over 2. All right. Here we've got what? Sine pi x. So this is going to be minus 1 over pi cosine pi x, going from 0 to 1/2. Okay. Sine of pi over 2 is 1. So we've got 1 over 2 pi. All right. You've got minus 1 over pi cosine pi over 2. Okay. Minus 1 over pi cosine of 0. You know, this is, you got to be careful here. You have multiple minus signs. Whenever you have a minus sign like this, then you got to be careful because it's like minus minus. So 1 over 2 pi minus 1 over pi. Cosine pi over 2 is 0. Minus, so, and this is 1. So plus 1 over pi. So 1 over 2 pi minus 1 over pi squared. So this is pi over 2 pi squared minus 2 over 2 pi squared. Pi minus 2 over 2 pi squared. Okay. I know with hyperbolic sine and cosine, it's the derivative of hyperbolic sine is hyperbolic cosine, and the derivative of hyperbolic cosine is positive hyperbolic sine. Okay, so let's make this the integral portion, because when we differentiate y, we just get 1. So u is equal to y, du is equal to dy, dv is equal to hyperbolic sine of y dy, so v is just hyperbolic cosine. All right, so u times v okay, minus v du. All right, so we've got 2 hyperbolic cosine of 2 minus 0 times hyperbolic cosine of 0, that's going to be 0. And then the integral of hyperbolic cosine is just hyperbolic sine. So 2 hyperbolic cosine of 2 minus hyperbolic sine of 2 minus hyperbolic sine of 0. So 2 hyperbolic cosine of 2 minus hyperbolic sine of 2 minus, or no, plus hyperbolic sine of 0. All right, so let's see. So sine h2 and then sine h0 is 0, okay? And then cosine h2. So 2 times minus this. Okay, I mean, that doesn't simplify, so it will just put 2 cosine h2 minus sine h2. All right, so when I see natural log of r, natural log of anything, you know, I'm immediately thinking that we want to differentiate that. But we could integrate that. It does have an integral, but to me, you differentiate it, and you get rid of that natural log. So, all right, so then dv is so then v is, would it be minus 1 over r? Because the derivative of 1 over r is minus 1 over r squared. Yeah. Okay. So all right, u times v minus, oh no, we want to evaluate this from minus v du. So let's take out that minus sign, and we've got, oh, this had a dr, right? Du dr. Okay, so we've got minus 1 over 5 natural log of 5 minus natural log of 1. Right? Minus 1 over 5 natural log of 5, and then minus, and then we plug in 1, and we still have that minus. Having a minus is confusing. Natural log of 1 over 1. Natural log of 1 over 1 is just natural log of 1. All right. Plus, and then this is going to be minus 1 over r. So let's bring that minus sign here. So minus, and then we'll have 1 over r like that. So we've got 1/5 natural log of 5 plus natural log of 1 minus 1/5 minus 1. Well, e to the 0 is equal to 1. So this is 0. So we've got 1/5 natural log of 5 minus 1/5 minus 5 over 5 is minus 4 over 5. So plus 4 over 5. Or wait, there's a minus here. Okay, yeah, so 4/5 minus 1/5 natural log of 5. All right, so here the key is, if you think about trig identities, there's a trig identity that should potentially jump out at you here. And I think what makes this trig identity hard to recognize is that we're used to, when we're trying to solve problems, we use this trig identity often in the other direction because going in the other direction makes the problem simpler. So the trig identity is sine 2x is equal to 2 sine x cosine x. And so we want to actually create this. That's going to make the integral simpler. So you see what I mean? Usually, for most problems, it seems like to simplify the problem, we want to change like sine of 2x into this. But here, we want to go the other direction. And so what we want to do is we want to say that we want to create a 2 sine x cosine of x. So we'll do x over 2 times 2. Okay, so what we've got is, we can say, so 1/2 x sine 2x, right? We'd rather this for integration. And so again, I think what makes it hard to recognize this is, if we saw a sine of 2x, we would think, oh, trig identity, right? Anytime I'm trying to solve a problem and I see like something of 2x, I think trig identity, but you never think in the other direction. But remember, for integrals, it's most likely desirable to condense down. All right, so this integral will say u is equal to x, so du is equal to dx, dv is sine 2x dx, so v is equal to minus 1/2 cosine 2x. All right, so then I'm gonna end up forgetting about this 1/2. I know it, but all right. So we're just gonna do 0 to pi Okay, u times v minus v du. So let's take this plus out, take the 1/2 out. All right, so minus 1/2 pi cosine 2 pi, and then cosine 0 is 1, but it's 0, x is 0, so okay. All right, then this would be 1/2, and then that's it. And then so we can do, so cosine of 2 pi is what? 1. Sine of 2 pi is 0, so this is just goes to 0. So minus pi over 2. And then times 1/2. So minus pi over 4. All right, so here I think they're just trying to get you to, if they put these weird variables in there, like a capital letter for the independent variable, just to test your understanding of the integration process. So, all right, this is, you think dependent variable with that capital M. So, all right, we'll say that U is equal to M, so we can just get rid of that. This is so confusing. Right, D lowercase u, D capital M, this goes to 1, and then dv is equal to e to the minus m, so v is equal to minus e to the m, or no, minus e to the minus m. Okay, so we've got u times v minus v du. So take the minus out. Okay, so yeah, so we're plugging in 5 into for the minus m. So we've got minus 5e to the minus 5 minus, and then minus e to the minus 1. Okay. Now this is, the integral here is minus e to the minus m, so let's make this a minus. And then we've got e to the minus m like that. So minus 5e to the minus 5 plus e to the minus 1 minus, all of this is in front of the minus is in front of e to the minus 5 minus e to the minus 1 minus 5e to the minus 5 plus e to the minus 1 minus e to the minus 5 plus e to the minus 1. Minus 5 minus 1, so minus 6e to the minus 5 plus 2e to the minus 1. So 2 over e minus 6 over e to the 5th. All right, so it's easier to differentiate a natural log. This seems like a tough integral. So u is equal to natural log of cosine x. So du is equal to 1 over cosine x times the derivative of cosine x minus sine x over cosine x dx, which is minus tangent x dx. Okay, dv is equal to sine x dx. V is equal to minus cosine x. Okay. So u times v minus v du. So it's just cosine x tangent x. What is cosine x times tangent x? That's sine x times 1 over cosine squared x. So sine x secant squared x. Or wait, no. Tangent x is sine x over cosine x. So times cosine x, you're just left with sine x. Okay. So we've got minus cosine pi over 3 natural log of cosine pi over 3, okay, minus cosine 0 is minus 1, natural log of 1 is 0, so okay, that's just 0. So we got this here minus the integral of sine of x is minus cosine x, so we'll bring that minus out. So cosine x so this is cosine of pi over 3 minus cosine 0. Cosine pi over 3 minus cosine 0, which is 1. So cosine pi over 3 is 1/2 minus 1/2 natural log of minus 1/2 minus 1/2 minus 1. All right, so 2 to the minus 1 power is 1/2. So, well, okay, what is natural log of minus 1/2? That you can evaluate that. Wait, cosine of pi over 3 is 1/2. Well, why was I? Okay. 1/2, so minus, oh, that confused me. Minus 1/2 natural log of 1/2 plus 1/2 minus 1. Okay. Yeah, so 2 to the minus 1 is equal to 1/2, right? So we've got minus 1/2 natural log of 2 to the minus 1. 1/2 minus 1 is minus 1/2. So we can bring this minus 1 out. And we've got 1/2 natural log of 2 minus 1/2. So 1/2 natural log of 2 minus 1. Okay, so I'm always going to default to putting natural log on the differentiation side, and even at the expense of having to integrate like x to the 4th, but that's not so bad. So v is 1/5 x to the 5th. du dx is 2 natural log of x times 1 over x. So du is 2 natural log of x over x dx. So okay, u times v okay minus v du. So we could take out a 2/5, and we've got what? X to the 4th natural log of x. All right, so it's gotten simpler. Instead of x to the 4th natural log of x squared, it's x to the 4th natural log of x. Okay, so u is equal to natural log of x. du is equal to 1 over x. dv is equal to x to the 4th dx. v 1/5 x to the 5th. So 1 to 2 u times v minus v du. Okay. So the integral of x to the fourth is 1/5 x to the fifth. So we've got 1 over 25 and then, kind of on its own here, x to the fifth. Okay, so 2 to the fifth minus 2 to the first. What is 2 to the fifth? Is it 32? 32 minus 2 is 30. 30 divided by 5 is 6. 25 divided by 5 is 5. So 6/5. Okay, so we've got 32 to the fifth divided by 5. So, well, let's do this. Yeah, we could do that. So 32 divided by 5, natural log of 2, minus, and then natural log of 1 is going to be 0 because e to the 0 is equal to 1. So it's going to be this, minus 6/5. Okay, so I messed something up. Let's see here. This was, so going from, this was 1 to 2 x to the fourth dx. So 1/5 x to the fifth. So that's 32/5 minus 1/5. And then there's a 1/5 out front. So this is going to be 31 over 25. So this ends up, this is 32 over 5 natural log of 2. Or 32 natural log of 2 over 5 minus 31 over 25. Okay, so this is 2/5 times 32 natural log of 2 over 5 minus 31 over 25. Okay, so we've got 32 natural log of 2 squared over 5 minus 64 natural log of 2 over 25 minus 62 over 125, or plus. And there you go.